Hello, this is a short series of presentations to assist paraglider and hang glider pilots who are studying for their BHPA pilot rating exams. This series is on meteorology. In this section, we will look at the concept of convection and its effect on the atmosphere. Convection is the action of the sun heating the ground. This, in turn, heats the layer of air closest to the ground, which will become warmer and thus less dense. It then may rise, and if it does so, it cools. The rate of cooling is around 3 degrees per 1,000 feet. As the parcel of air rises, it may reach a point where its temperature reaches the dew point, and the water vapour it contains condenses to form cloud. Cumulus clouds are formed in this way. The rate of cooling after the dew point has been reached and the air continues to rise is less, at around 1.5 degrees per 1,000 feet. The rate of cooling of air parcels as they rise is known as the lapse rate. For air containing its moisture as a gas before it has condensed, the lapse rate is known as the dry adiabatic lapse rate, or the DALR. Once water in air has condensed and cloud is formed, the rate at which the air continues to rise is known as the saturated adiabatic lapse rate, or SALR. This rate of cooling is less because the act of condensation releases heat. This heat energy being released is known as the latent heat of condensation. The key numbers here can be expressed both as degrees per 1,000 feet or in degrees per metre. The BHPA pilot exam generally uses degrees per 1,000 feet when asking questions about the dry adiabatic lapse rate or the saturated adiabatic lapse rate. Under the right conditions, the normal vertical temperature gradient can become inverted. This means the air is colder near the surface of the Earth or becomes warmer rather than cooler with altitude. A common inversion in the winter months of the UK is the cloud that fills the valleys or lies on waterways in cold weather. In hot summer months, layers of warmer air may cause rising air to stop climbing. These inversions can look like layers of haze or dust across dry valleys. The bottom right image shows a strong inversion across the valley in Porterville, South Africa. In thermal cross-country flying, pilots often find their thermals slowing and getting more turbulent as the rising air bubble meets a layer of warmer air that arrests the rise of their thermal. Radiosonde balloons are balloons used by meteorologists to measure the temperature, humidity, and wind speed of air as a balloon rises through the atmosphere. At certain sites around the world, these devices are released twice a day to help scientists plot the state of the atmosphere above. The resultant chart is frequently referred to as a tephigram or skew-T. These can be quite technical to interpret, but provide pilots with an impressive amount of information in relation to the state of the air mass in which they hope to fly. The graphic in the top right of this slide is an example of a tephigram for a good flying day in Europe. That's about all we need to understand about convective heating and its effect on the air for the pilot exam.